Alright, so let's go ahead and prove some simple additions using the Peano definition. So, for example, we might have the problem prove, using the Peano definition of addition, 3 plus 2 is equal to 5. Now, if we're going to prove that, it may help to have the Peano definitions down so we can refer to them. So there are two parts. The first is the successor rule. N plus 1 is the same as the successor of n. In other words, n plus 1 is just defined to be the number after n. The other part of the Peano definition of addition is that n plus the successor of k is the same as the successor of n plus k. In other words, n plus k star is the same as the number after n plus k. Alright, so let's try and organize our proof, and what we can do is we can compare what we're trying to prove, 3 plus 2 is equal to 5, against our Peano definition of addition. So let's take a look at that. Our first line deals with the additions n plus 1, and so we might notice that we're not actually dealing with an n plus 1 addition. We're adding 2, not 1. So we don't want to start with that first line of the Peano definition of addition. On the other hand, if we take a look at what that second line is, n plus k star, that does look promising because remember, k star is the number after k, and we do know that 2 is the number after 1. So it seems like we can start with this second part of the Peano definition of addition. So let's go ahead and try to organize it that way. We know that 3 plus 2, well, I can write that as 3 plus 1 star, the successor of 1, because I know 2 is the number after 1. And at this point, I can invoke my definition. I know that n plus k star is the same as n plus k, take the successor. So 3 plus the successor of 1 is the successor of 3 plus 1 by our definition. Now, I also know that 3 plus 1 is the same as the successor of 3. And there's our first definition. There's our first part of the Peano definition. I know what plus 1 is. Well, I can go further than that. I know what the successor of 3 is. It's the number after 3, otherwise known as 4. And once again, I'm in the place where I am looking for the number after 4, the successor of 4, and that is going to be 5 by our definition of what 5 is. And important note, we're going to connect first line 3 plus 2 to last line 5, and that's what we're actually trying to prove. 3 plus 2 is in fact equal to 5, and so our proof is completed at this point. So here's an important question. What do we actually need to write down to have a complete proof? Well, for a complete answer to the question, the things that you must include are those portions that are in blue, which is to say you have to include everything from your initial statement all the way down to this last line, including all of the justifications for every step that you take. Anything less than that is not a complete answer to the question, prove using the Peano definition of addition that 3 plus 2 is equal to 5.